Hello everyone, this is the video lecture for Calculus 3, section 12.2, Vectors. Okay, so to be honest with you, I did most of this lecture and then I really fumbled on something, and so I started over. So I'm going to try to not remember all that. I'm going to try to focus on what we're doing. Here we go. So vectors, what are they? Well, we've seen this back in pre-calculus. Two-dimensional vectors look something kind of like this, or something like this. So those are two-dimensionals. We've seen them with the what I call alligators, but they're just that greater than, less than symbols, essentially. So what it's trying to denote is an xy coordinate for the vector to end, kind of like a point. See, this is the point, while this is a vector. Very similar. And so the idea is that it's going out to a point, and the vector is that, I guess you can call it a ray going out until that point. So 2, 3 in particular, if you wanted to draw a 2, 3, 1, 2, 1, 2, 3. Well, it's close enough. 1, 2, 3. Just like a point. Okay, so that's good. Another style that they sometimes do this, or is the what I call component form. Maybe I'm wrong on the name, but they use I, J, and K. This is just a component right here, just a piece, and I use that little hat to symbolize that it's like the X component, the Y component, the Z component, instead of a variable. So there you go. Alright, so now we're of course going into 3D mode. So 3D mode, we've seen this from the last lecture, but a vector can come out essentially from the origin. It could be not coming from the origin also, but typically we're thinking of them from the origin. So as an example, we can have 2, 3, 4, and of course with the IJK method, we can have, there we go, 2, 3, and 4. So either way, they're equivalent. As we keep going, a little note here. They're going to use like vectors with bold and all that. I can't draw that every time, and so what I do for vectors is a V with a little line on top of it. So that indicates that it's a vector. Okay. One last thing about vectors before we move on. You can add them, you can subtract them, and you can scalar multiply them. So what would that look like? Well, let's say that I have two vectors graphically, A and B. And so then they said, hey, find A plus B. And so what I would do is I would take an A, and then I'd take a B, and I'd put them together, back to back. Well, I guess it's like tail to head, head to tail, something like that. Anyways, you just connect them, and then you have an AB vector there. That dashed one is your, I guess, A plus B. If you had, say, A minus B, you would go an A, a positive A, but then you would go a negative B. See, B was going to the right, now it's going to the left, that's a negative B. And so your result would be that little dashed line right there. And again, we could do 2A. So we got an A and we got another A. So total, that line, the big long line, would be a 2A because you essentially doubled it. Okay, cool. Now that we got all that out the way, let's start doing some actual math problems here. So 2, 15, 12, 2, 15. They give me an A vector that is -3, 4. It's an equal sign there. Kind of weird. And we got a B vector, which is 7, -1. And they want to know, what is A plus B vector? So we're going to essentially add up our X components. So that would be a 4. We're going to add up our Y components. That's a 3. There you go. And you're done. If you want to graph that thing, 1, 2, 3, 4, 1, 2, 3. So about right there. Next problem. So now let's do a three-dimensional. 12, 2, 0, 1, 7. So I got an A vector now of 301, 301. and I got a b vector of 0, 6, 0. And so when they say, oh, find a plus b, well, I'm just going to add up my x's. That would be a 3. Add up my y's. That would be a 6. Add up my z's. That would be a 1. There you go. So there's your answer. If you wanted to graph this, x, y, and z, so I would say 1, 2, 3, 1, 2, 3, 4, 5, 6. Just like in the last lecture, it's kind of like your shadow here. And then I would go up 1. So up 1, so that would be my true point right there. Point P, I guess you can say. But then the vector is the line going to that point. And there you go. All right, next question. 122019. It's kind of funny. I feel like they use the same numbers again and again. So negative 3, 4. B is a 9, negative 1. So they want a plus b. That was easy enough. So when you add them together, I got, what, 6 and 3. So there you go. That was super easy. They want then 6a plus 7b. And so what I'm going to do is put a 6 in the front and a 7 in the front. And I'm going to pretend kind of like they're parentheses in a way, where I would distribute into them. And so I got negative 18, 24, and then plus, here I got 63, and then a negative 7. Adding your x components together and y components, I got 45 and 17. So there we go. And I used the calculator on that, so I know, bigger numbers, it gets really tough in the brain. They want this new thing called magnitude. Magnitude of a vector. Magnitude is simply a distance. It's simply a distance. And so you might be thinking, oh, well, that looks like absolute value sign. Well, kinda. They do actually look the same. That's true. But let me kind of give you a type of an example on the side here for a second. Let's say I have the absolute value of negative 3. And you can say, oh, well, I know that one. That's 3. But I'm going to tell you, I'm saying that absolute value is technically a distance. Let me prove it to you. So what if I had 0 over here? 1, 2, and there's negative 3. What's the distance here from the origin? That distance is 3, isn't it? A 3 distance from negative 3 to 0. So that's what I'm finding here. This is actually a distance for the absolute value. Now, with like, and I'm just making something silly up here. What if I had it like a single dimensional vector? Well, then it would still be the 3 again because I'm just wanting that distance. What's that distance of that little arrow right there? How much distance we got? We got 3. Really, we don't ever see this. I'm just making a point that it's actually a distance. So, if I were to find this distance of a, negative 3, 4 here, and they want the distance, well, we use a formula we've already been using. It's the Pythagorean Theorem. Well, I didn't spell it right, but it's close. So how does that work? You would say the square root of the negative 3 squared plus the 4 squared. So we got, what, 9 plus 16. Square root 25 is 5. But we probably could have saw that 3, 4, 5 triangle. So pretty easy there. Okay, last one. A minus b, and then the magnitude of that. And so magnitude of negative 3 comma 4 subtracting, was it 9, 1? 9, negative 1. 9, negative 1. Oops. And so, of course, you start with the stuff on the inside. I have, that's actually going to be distributed into there, right? So negative 3 minus 9 is a negative 12. 4, 2 negatives make a positive, so 4 plus 1 is 5. And so when I find the magnitude of this, it's simply Pythagorean Theorem, and, well, it turns out to be 13. 5, 12, 13 triangle, which is just nice. Anyways, I want to show you one other notation. So often in this book, and I like that, for vector v or a or whatever, they're using single lines here for magnitude. That's good. But it's also absolute value. Just I get kinda again. If you're working with a scalar, it would be technically absolute value. But because we're working with vectors, we call it magnitude. Again, distance. They're all the same. But now in other books and other places, they sometimes use the double lines to indicate a difference. Like, hey, we're working with a vector here. It's not just absolute value. That's okay. Sometimes I might do it, but I really like sticking with the singles personally. Some formulas have a whole ton of them, and so it gets really weird when you get like, you know, here's an example here. I have two magnitudes multiplied together, and you can see that's just crowded. That's just very crowded when I could just do something like that. Okay, it's a little better. Maybe put a little dot in there to say, hey, I'm multiplying. But you can see 4 lines right here. Just it looks ugly. So there you go. All right, just wanted to let you know. Moving on. Next question, 122025. That's a 2 right there. Okay, so they give me an IJK format vector like this. So 2i minus j plus 2k. And they want to find the unit vector with the same direction. So that's interesting. What do they mean by that? Well, unit vector basically is magnitude equals 1. The magnitude of that vector, that answer that they want, has to have a magnitude of 1. And so there's a little formula for it. We got vector v divided by magnitude of that v. What happens is that the magnitude cancels out its distance, leaving you with a magnitude that equals 1. For example, if I had, say, like 5 as like a vector and I divided it by 5, you would probably assume I would get a 1 out of that. You know what I mean? Because the 5's cancel and you make a 1. That's going to be the same kind of concept. Now, I know we don't use that single stuff here. I'm just saying that's the style that we're going to be using. So let's first off try to find its magnitude. And so I would say Pythagorean Theorem, 2 squared, 1 squared, 2 squared. And notice that this was a -1 right there. And all I'm doing is picking those numbers and putting them in here. One other thing, that's a -1. Why did I put a +1? Well, I know that -1 squared is going to be a +1. So I don't really have to write negatives here ever. I just know they're going to be positive. It's not a big deal, you know. Square root of 9 equals 3. So that's going to be our magnitude. What we do then is take our original vector and we divide it by its magnitude, just following this formula right there. So you distribute that 3 into all 3 of those. Oops, I already did the equal sign. And so I would get 2/3, -1/3, 2/3. And there's your final answer. If they wanted it with the I, J, and K, you can do that, of course. By the way, those I, J's, and K's are found on the side tab. When you click on a question, it often pulls up with a box on the side, and you can just pull it from there. I find it really slow, so I try to not do it if at all possible. I like this style like every time, but that's just me. Okay, another one. I got 12.2.029. So they say we have a vector v in quadrant 1, so that's a good indicator of what we're looking at. It says that the angle that it has with the positive x-axis is pi over 3. So with positive x-axis. I know it says positive there, but it's quadrant 1. I would assume it's probably positive x-axis. They also say that the magnitude of v is equal to 8, and they want you to write it in component form or whatever, but I mean, it's just, I don't know. The alligators work fine. So what kind of formulas are we going to be using here? Well, this goes way back to pre-calculus. X equals r cosine theta, and y equals r sine theta. If you haven't seen these in a while, they're very important. Write them down. They're very, very good. basically this magnitude is represented as an r, a radius, a magnitude, a distance. They're all the same. So we're going to use this for that r. And of course, you can probably guess what theta is equal to here. So tossing them both in, here we go. My answer would essentially be 8 cosine pi over 3, 8 sine pi over 3. And of course we know what those cosines and sines are. I'm pretty sure it's 1/2 and square root 3 over 2. And so thus my final answer would be 8 cut in half is 4. Again, the same thing, 4 square root 3, and you're done. So there you go. Pretty easy. Next one, 12,2,0,32. So this is the problem that I basically messed up on last time with my other recording. I didn't really get it wrong. I went off track and then I kind of confused myself. So I have two vectors here, A and B, and they are pulling at these two different directions. Now the picture says 45 and 30. They don't actually include that negative sign. But you know that down here, if you're going down into quadrant 4 from quadrant 1, you're getting a negative value. So make sure that's a negative 30 when you do it in your mind. They tell me that the magnitude of A is equal to 26. And then they say that the magnitude of B is equal to 12. And their answer is saying, hey, what is the magnitude and the direction of the resulting vector? And here's the idea. Let me redraw it. I have this big old box here, this crate, and I have one person here pulling on it like it's a rope, you know. And then I have someone right here also pulling on it, kind of like a rope. And so this person's pulling and this person's pulling, but you can see that this one's pulling a lot more, 26, versus here just 12, so not as much. So this one's pulling really strong, this one's pulling a little bit. Where is the resulting vector? Where is it going to end up? And my guess is it's going to be somewhere here in quadrant 1 because he's got most of that magnitude going on. What you could also do, if I drew it correctly, like in a way, I have that 45 and then I have the 30 that's a little bit smaller. I can actually do this thing called the Parallelogram Rule or something, and you can graphically copy paste them, and then you could then basically see where they end up right there. So that would be your resulting. And then you can see why I'm thinking I'm going to result in quadrant 1. By just doing it graphically, I could see that. And so I'm expecting positive answers in both my x and y in the end. Okay? So let's go ahead and start doing it. What I'm going to do is break these down into x and y, add them up, and then I'm going to go from there. I know they're asking for something else, but let's just start with that. So let's start with the x and y for the first one. Again, x and y, we just saw these formulas a second ago. I'm going to have the 26 cosine 45, 26 sine 45. Okay, so that was the first one. The second one is the 12 cosine negative 30, and then 12 sine of negative 30. Okay, I think my drawings are going sideways here. I'm going to try to remedy that a little bit. I want to add up these two together, add up those two together to get my final x and my final y. That's going to be my answer here in a second, basically. So here we go. This is going to be basically me adding them up. I got the 26, scroll just a bit, 26 cosine 45 plus the 12 cosine negative 30, comma, 26 sine of the 45, and then plus 12 sine of negative 30. Cool. Okay. Well, you could get kind of exact answers out of all this. Here we got square root 2 over 2. My cosine of, that looks bad. Here would be a square root 3 over 2. Square root 3 over 2. This guy is square root 2 over 2, and this one is a negative 1/2. So, like, you can already put these together, and you can half them and all that stuff. So let me just give you the answer that I came up with. It's not really that much simplified. So I got 13 times square root 2 plus 6 square root 3, comma, 13 square root 2, and then minus, and then just 6. What's half of 12 is 6. So I'm just simplifying this down to this guy. I know we can all do this. It's calculus 3, you know. So cool, right? We got our x's and y's, but they weren't asking for that. They were asking for the magnitude and direction. So we actually got to go a step further. They're saying, what is my r and what's my theta? Again, I say r, but I mean magnitude, I mean distance, I mean absolute value. There's a lot of, I mean, they're all kind of together, you know, they're all the same concept. And angle, direction, they're all the same. So how do we make these things happen? Well, just like we had these formulas a minute ago, in fact, we just used them, right? There's two other formulas, if you remember. It's that r squared is equal to x squared plus y squared, and that my tangent theta is equal to y over x. So these are the other two that I'm going to be using in order to find r and theta. And so, obviously, to find r, what would you do? You square root both sides, essentially. Pythagorean Theorem, all over again. So let me do the Pythagorean Theorem with this to find my magnitude. So here we go. And you might be thinking, whoa, what is going on here? I have something good in just a second. Let me keep writing. Almost there. I want to make one small point, okay? Notice how I retain that minus sign right here. That's important because it's not like I'm saying, oh, -3 squared. It's not just that. I'm actually doing some math like 1 minus 2 squared. If I made that into a plus, I would get a whole different answer, okay? So it's good to, you know, cheat it a little bit, but make sure you're doing it right. Blah, blah, blah. I use the calculator. And that's okay because they were wanting a decimal answer anyways. So there's my decimal answer. I don't know how many they round to. It goes on forever, but that's basically the answer. Calculator good. The angle, my theta, is from the arctangent. And so arctan of the y over the x. Cool. Again, I use calculator, 23.285 ... degrees, basically. So there you go. And again, is this quadrant 1? Oh, yeah. So that makes sense. That's a good check. It makes sense graphically. It's somewhere like over there, right? Which is good. Make sure that your calculator is in degree mode. I know that we're going to go back and forth between radians and degrees all throughout the class, but obviously when they're asking for degrees, make sure it's degree mode. Okay, I have one last question for this section, so here we go. 12-045. Okay. This one actually takes a minute. So I got 3 vectors, A, B, ooh, that's a terrible B. That's a little bit better. So that's a 4, -1. And then my C is 9, 1. Excellent. They're saying that C vector is equal to SA vector plus TB vector. And they want to know, what is S equal to? What is T equal to? And they actually want to know the decimal for it, and they also want to know the exact value. And I'm going to basically show you how to find both of them. They're pretty easy. Okay, so what do? I'm going to set it up. I'm going to just draw out whatever they had, their statement right here. I'm going to draw it out with actual numbers. And so I got this, I got an S. Don't mistake it for a 5 or something. I don't think there's any 5s in this problem right now. Okay. And so what I do is I distribute my S, distribute my T, and so I come up with 3S, and you can add them. I'm just going to go ahead and jump to it. plus 4t. Those are all my x's. And then my y's, I got 2s. Man, that looks like 25, doesn't it? Okay, it's the best I can do. Minus t. Just, there's no 5s here, okay? There's no 5s in this problem. So what do I do now? Well, this is supposedly equal to 9, 1, right? So this should be 9, and this should be a 1. And so basically 9 is equal to 3s plus 4t, and 1 is equal to 2s minus t. So these are my equations. Can you guess what you can use? Oh yes, you can use a matrix. Wow. Do y'all remember matrices? I'm gonna assume no, because I'm not gonna end on this, but you can RREF it. Again, RREF if you remember that. And so I did that. I'm gonna show you what I got. 1001, which is good. I got 1.181818. Here I got 1.363636. Okay, and they go on forever, obviously. You could, on your calculator, if it's like the TI, you can do math to frac. Math to frac, that's a little triangle. If it's a Casio, you can do FD, fraction decimal. And it should convert this over, and I'll just show you the answers now. S is 13/11, and T is 15/11. So there's your final answers. You can use these for your answers and those and etc. Because I think they're wanting these for part A, and then these are part B. Regardless, it's fine. Let's just say that you are confused about these matrices, right? So, like, what is going on? Well, you can just do this equation stuff by yourself. Like, what if I move the t over and move the 1 over? So, I would get t is essentially equal to 2s minus 1. So that's not bad. And I'm going to plug it in right there. So here we go. 9 is equal to 3s plus 4t. And then I can start solving for s. So distribute the 4. Okay, cool. Combine these two together. 8 and 3 makes 11. S. Move the 4 over, so you're adding 4 to make a 13. And you can see, divide by the 11. S is equal to 13/11. Then you can take this and plug it in here and blah blah blah. T is equal to your 15/11 again. So there you go. You can do it the long way. That's totally fine. Either way is acceptable. So that's the end of this section. Wasn't too hard. If you got any questions, let me know. Thank you very much. Have a great day.